Okay, so I'm going to continue support for more instructions. This time I'm going to look at some comparisons for like floating point values. So I'm going to start with this CMPSS one here. So CMPSS allows for the operand encodings for these are RMI and then RVMI. And this is a bit different from other instructions I've done so far because these ones actually allow support for a K register as an actual operand here, which means that I can use K0 in this case. Whereas when it was, for example, like an Opmask, you can't use K0 because 0 is an Opmask, means there is no Opmask. So K0 as an actual operand, though, is actually valid. So I'll test with K0 here, I think. So we've got CMPSS with RMI. So we'll do XMM0, XMM1, and then for the immediate, I'll just do 7F like I usually do. Then we've got a memory access. Then we've got the VEX version, which is the same thing, but there's an extra operand in here. So this one can be XMM2, and I'll add XMM1 in here. Then we got the EVEX version, which uses K1, or a K register as the first operand. So we'll use K0, and we'll put the K1 as the Opmask. There's no zeroing here, so we won't do Z. And then there is SAE, suppress all exceptions, for this register version here. So we'll put that on the third operand there. I think you need a comma for this. Let's just generate that. Yeah, so I need a comma there. Okay, so that's CMPSS, I think. I think that covers all of the forms. So we'll just do a copy of this for SD as well, because that's basically the same thing, it's just a different mnemonic. Then there are these packed versions as well. So we've got CMPPS, and this is pretty much the same thing again, but we now have broadcasts on the EVEX encodings. And we have the ability, for example, in VEX to go up to YMM, and in EVEX to go up to ZMM. Though with the EVEX ones all use K register as their first operand. So we'll just copy, for example, CMPSS, because it's pretty much the same thing still. So this will be PS instead. And for the legacy encoding, nothing's really changed. Same goes for VEX encoding, nothing has really changed except for the fact that it now supports YMM as well. And then for the EVEX encoding, we also need a test for broadcast. So this is 1 to 4 since it's 32-bit elements. Then if we go and do YMM, this now needs to be 1 to 8. And then if we do ZMM, this will now need to double again to 1 to 16. Unsupported mode decorator on 318. So suppress all exceptions is only available for ZMM in this case. Then we got the same thing again for PD this time. But because it's a double precision, that means it's 64 bits, so the number of lanes in the broadcasts have to halve to 2, 4, and 8. Okay, so that's the first sort of batch of comparison instructions. I'll implement these first in the encoder test. So we'll just take all of these comp ones here. I'll actually deduplicate these and uppercase them, prefix them with op, and put them into we'll do, I think it was convert was the last ones in here. Okay, so we'll put them under here. And then we'll go and look for the forms so that I can add some empty form tables. Okay, so back to the tests again. Let's comment this out, add the mnemonic. So these are basically going to match on the vector length. So X word, Y word, Z word. Then we've basically consistently got V0, V1, and then we'll do V2, but then an immediate of OX7F. And then for these ones up here that have 3 operands, which is all of the legacy ones, in these cases they don't have V2. So we'll take this one out. Let's just go get those again. So in these cases, the final operand will be NA. So all of these ones are X word. Oh, and I also need to cover the K register as well. So these ones are all K0 in the first operand slot. So this is K0, and then I've put a K mask on it of K1. Then we've got a V1 again, and I also need to put in the memory accesses as well. So we've got memory access on these. Yeah, so memory access is always before the immediate in these cases. So we'll just go and take all of these. We'll find the immediate, and the operand before the immediate is CX as a memory access. Then we've got the 1 to something syntax here, which is the same thing. Did I do? Oh, okay, I see. I forgot to remove the comments for these other tests here. Let's just go and take all of these tests. And remove the comments so that I can reliably get all of these 1 to something syntax things here. So these ones need to be a broadcast. And I think that should be about it. So I'll just remove these comments for now as well. And then one of the things I'm going to have to do is that when doing a K Opmask, this is going to check to see if it's vec or memory, and now it needs to check if it's vec or kreg or memory. So this can only apply to vector, k, reg, or memory operands. And actually this kreg as well, we need to check to see if kreg value is 0, then we need to do this panic as well, because K0 cannot be used as an Opmask. Okay, so let's just do the test here. Okay, so all of the operands are being constructed correctly, so now we just need to fill in the forms. So we've got CMPSS. Let's go to the forms and find CMPSS. So these are all going to match. Actually, I need to do the matching, the sizes. So these ones were all XMM anyway, so these are all X word. But where we've got Y word here, these need to change to Y word. Then we've got 3 X word, 3 Y word, and 3 Z word. And then the ones down here, the other packed ones, are just the same thing again. Okay, so CMPSS is going to match on the width of X word. The op-n for this is op-n RMI. So op1 can be a vec, op2 can be a VEC or memory, and then op3 can be an immediate 8. So it's always restricted to a single byte here. So for these ones, we have a prefix of F3. We have a map of 0F, so the secondary opcode map, and then we've got the opcode itself, which is C2. Then we need a couple of others, so we've got family. Here is VEX for this one. VEX is still C2 here, and then the difference between VEX and EVEX is just whether you're using the features that require EVEX or not. So I should be able to just copy this and do EVEX as well. So they will have the same prefix, map, and opcode. Then we've got VCMPSS. Oh, so VCMPSS actually is not matching here because I need to do a different op-n for this. This is RVMI, which I'm not sure I have. Oh, yes, I do. Okay, that's fine. So this is VEC, then op2 is going to be VEC, op3 is going to be VEC or memory, and then the op4 is going to be the immediate. So I'll copy that into VEX. And then I'm going to need to allow K registers in the first operand as well for... Oh, actually, this one is just K-reg for EVEX. Okay, so that is still not met. Oh, okay, op3 needs SAE, and I think we need broadcast as well. And then op1 needs K-reg, but it also needs Opmasks. Okay, so now we're just getting some incorrect encoding here. So it looks like P2 is incorrect, and that it needs the B flag set for this one. So this is RVMI. Let me just go and check. This is because the encoder test doesn't set SAE yet. So I need to go and find all these SAE ones. And then V2 in these cases needs SAE set on them. Okay, so now it's moving on to compare SD. So those forms all work, and the encoding is correct. So SD is basically going to be the same thing, but I imagine the opcode or something is going to be different. So SD here is still C2. It's actually the prefix is now F2 instead. So F2. That should take care of those. Oh, I need to change this to SD. Okay, so now we've got incorrect bytes for this one. So this one is actually, it looks like maybe it's the W flag. So we've got W on EVEX here. Because it's a 60, I guess because it's 64-bit, because it's double precision, so we've got W as W1. Okay, so now we're on to CMPPS. So CMPPS has a few more forms, but it's still opcode C2. The difference being here that W is set to 0 on all of these, and there's no prefix. So I think probably if I copy all of these, the SS and the SD, so this one is actually PS, and then these ones down here would be PD, but I'll get rid of the prefixes. Okay, so VCMPPS is not matching in this case. So VCMPS, this is because I need to add Y-word to the match. And then this one will need Y-word, but SAE is only supported on Z-word. So I'll take this one out and put Z-word separate, and then take SAE off of these two here. And then we'll do the same thing for this, which is that VEX needs to support Y-word, and then EVEX needs to support X-word and Y-word, but this one doesn't need SAE anymore. And Z-word should keep SAE. So VCMPPD, it's got the correct opcode. So it looks like it's basically just that something in P1 is not being set. So it needs to set K1, I think. So let's just go to the form table. So we've got, is this PD? PD, CMPPD is the only one that's failing here. So CMPPD, oh, this actually does have a prefix of 66. Okay. So I need to just go and find all of these map ones. I imagine they all have the prefix of 66. Okay, so that's the first batch of comp instructions. The next ones that I wanted to do were pcomp. So there's pcomp equals with B, W, and D, and then there's a Q one here as well. So like the other instructions that I've implemented, I'll be ignoring MMX forms here. But these ones are basically going to be the same as the other comp ones that I just implemented, because they also have these EVEX forms that accept a K register. So all of the EVEX ones accept the K register, whereas all of the VEX ones accept just the normal vector register here. Yeah, so they will just go down into K. Then we've got on the next page here, we've got the Q version as well, which is the same thing where EVEX just has the K register as the first operand. So I think that what I should be able to do for these is, since they're pretty much the same as the comp PS and comp PD ones, I think I can just copy those and just make some changes. So if we just copy, say, this one. So this time it's pcomp equals. So this is a pcomp and then we have, for example, B for byte, W for doubleword, D for doubleword, and then Q for quadword. So we'll just start this one with B. And so we've got the operand encodings for these are a little different in that they don't have an immediate. So I can get rid of the immediate from all of these. But other than that, they stay the same. So they're still RM, RVM. And so we've got, so let's have a look at B first. So B here, ignoring the MMX one, is still just RM. Then we move up to this one, which is W. So actually focusing on B, we've got RM. The next B one is VEX, which has the memory as the third operand there. And then we've got B, I think. Yeah, so here's the EVEX one with B, which has 3 operands. And then it looks like there's no broadcast here, so I can get rid of the broadcast tests. And I don't think there's any SAE here as well, so we can get rid of that. These ones here have a broadcast though, so this is like D is being broadcast. But the B ones don't have broadcast, so maybe I'll just... so we've got broadcast for D. Does W have broadcast? W does not have broadcast, so it's only the D one that has the broadcast on it. Maybe I'll just keep these here. Let's just redo this. So we've got unsupported decorator, yeah, because this still has SAE on it. So this is going to complain about broadcast because broadcast isn't on the B one. But we'll make a copy of these for W. And we'll make a copy for D and Q as well. So here we've got D, and then down here we'll have Q. When it comes to the Q version, this one does have broadcast as well. So I think that should be okay. So I just need to take off the broadcasts for W and B. Get rid of those tests. Mismatch in the number of elements. So this is 394. Okay, so this one is, if we go to XMM here, so these ones are all memory 64, which means that I need to halve these. So this is now 2, this is 4, and this is 8. Okay, so that's those VComp ones. And then there's these PComp greater than ones as well, which look like they should also be the same, just with a name change. So we'll just take all of these, and instead of it being comp equal, it will now be comp greater than. Okay, so now let's go and take all of these into the encoder tests. Okay, so I think maybe I'll just take all of these by searching for PComp. Okay, so let's comment these. We'll bring these into a new file, deduplicate, uppercase, and then put the prefix on them. So these ones can go into, we've got comp SS, for example. We'll put these below this block. Create some empty form tables. And then start implementing these tests. So we've got uppercase this again. Put op before it. Then we've got, we'll just do xword for now. Then we've got 3 operands, but 2 operands for the legacy ones. So we'll do V0, V1, and V2, and then NA. So for all of these legacy ones here, which are all just PComp something, we'll take out V2. This can now be NA. Then we need so we've got RCX. This one is the memory access. Maybe we'll take that out last. We'll just say if we've got RCX here, we'll set all of these ones to have V2 as CX with memory. Then we'll take care of these broadcast ones quickly. So this is now CX with memory becomes a broadcast with B. Then we need to do these K0 ones. So this is V0 changes into K0 with a K mask of K1, or an op mask of K1. Then we need to get rid of the third operand for the legacy ones. So this is pcomp something. And in these cases, we've got V1. These ones should... we'll get rid of this operand and put NA on the end. Then anywhere that we see V0 followed by a V2, we'll change this to V1. And then we just need to sort out the widths. So these ones here are YMM. So that's Y word. And then we've got ZMM, which should be Z word. Okay, so let's just run these tests now. Okay, so now we're not matching the forms, so I can just go and implement the forms. So this is a pcomp equals. So we'll start with pcomp equals B. So this is a prefix of 66, secondary opcode map, and then opcode is 74. So I guess for this one, we'll just write it out. So we've got a width of X word. Op n for this one is RM, because this only has two operands. Then we've got op1 is vec. Op2 is vec or memory. Then we got prefix is 66. Map is the secondary map. Then the opcode was, I think, 74. Yeah, and then we've got the rest of them are all the same prefix, W0, so I don't need to set that. The opcode changes between these, so B is 74, W is 75, and then D is 76. Let's go and have a look at Q. Q is completely different, which I guess is, why it's separated out. So we'll get to that one in a minute. But the opcodes for these ones at least just count up. So let's just go and put one in for this vex encoding. So we've got family is vex. Vex should support X word and Y word. I'm pretty sure it does anyway. So we've got B here with X, and then we've got B here with Y as well. And this one is RVM encoding. RVM. I need to add the op-n prefix to this. So we've got vec, then we've got op2 is also vec, and then op3 is vec or memory. So we've still got 74 for B, so that's fine. Then we've got evex. Evex should match on both of these. This is also RVM, but this time instead with evex, if we go and look at evex B, this is kreg with opmask. Then we've got vector, and then we've got vector or memory. So that seems like it should be okay. And actually, I don't think there's any difference between the ZMM one here as well. So we'll go and look at for ZMM with B, and that looks the same as well. So this one can also just match on Z word. Okay, so now it's on the W one. So the W one is just a copy of this with W, and the opcode has increased by 1. Then the D version is the same thing. but we've increased by 1 again in the opcode, so this is 7, 6. And then we've got Q, which is different, but I'll start with a copy of these. So QD now becomes QQ. And then the difference here is that this one is still 6, 6. This one is actually opcode map 0F38, so the map has actually changed here. So this is 38. And then the opcode for this one is 29. And that looks like it's the same for all of them. And then for EVEX for this one is W1. There is memory broadcast for this one, and there is memory broadcast for, I think it was D as well. So on the D version, we've got memory broadcast for when it's ZMM. Yeah, so all of these D ones need to support broadcast, but I suppose we'll just see the failing test for that first. Yeah, okay, so this is broadcast. And now we're on to the keyword one, which also needs to support broadcast, because this one is also failing on the 1 to 2 version. Okay, so now we're on to the GT instructions. So I imagine that these are basically going to all be the same things with a few differences. So we'll change EQ into GT. And then for GT, we've got no prefix. Vex has the prefix of 6, 6. Oh, no prefix is the MMX one, which I'm skipping. So prefix is still 6, 6. Then we've got 6 instead of 7 for the opcode. And then down here for the Q version, this is 3, 7 instead of 2, 9. So instead of 2, 9, this will be 3, 7. And then here we've got, instead of OX7 something, this is now OX6 something. Okay, and that's all of them implemented.